I think I remember what's special about this one. Let's go ahead and multiply it out because for complete the square, we don't want any sort of factor, anything to start off with. So I have a 2k squared minus 4k plus 3k, which is just minus k, and then minus 6 equals negative 15. Okay, so first thing I want to isolate the k squared and the k. So I'm adding 6 to both sides, which is going to give me negative 9. Then I need to get 1 in front of the k squared, so I have to divide by 2. K squared minus 1/2 k. Remember, k divided by 2 is the same as 1/2 k. Dividing is always the same as multiplied by the reciprocal. We say that for fractions, but it's true for anything. Dividing is the same as multiplying by the reciprocal. Equals negative 9/2. Okay, if nothing else, this is at least another good fractions example because those are always hard for people. So I'm supposed to take negative 1/2 and I'm supposed to cut it in half, divide by 2, which is the same as multiplying by 1/2, and then square it. So I get negative 1/4 squared, which is 1/16. Okay, so let's see, we need to multiply top and bottom by 8, which is negative 72 over 16. So I'm going to have negative 71 over 16, that's hideous, is equal to, and here's the factor step that gets tricky when there's fractions for people, I know. What I want is 2 of the same thing that add up to negative 1/2, so that would have to be negative 1/4 plus negative 1/4. So if I multiply negative 1/4 by negative 1/4, I get 1/16. And if I add negative 1/4 to negative 1/4, I get negative 2/4, which is negative 1/2. Okay, so complete the square. Now I need to solve. So first I'm going to go ahead and take the square root of both sides. Okay, whoa. I don't know how I just got an extra line there. K minus 1/4 is equal to plus or minus the square root of negative 71 over 16. Now you could certainly split that up and say, oh, the square root of 16 is 4, but I don't even care because there's something much bigger going on here. Oh, excuse me, yawn. I am ending up with the square root of a negative number, which is not a real number. So I mentioned in the factoring section that quadratics absolutely can have no solutions, and here we're finally getting to see how that would play out. I was trying to solve this equation, and what I got down to is just that I'm not even getting an answer. There is no real answer to this. So it's not that I got a good answer and I threw it away. It's that I couldn't even get a good answer. So I'm just going to say this has no solution. Okay, so watch for that. You will see that happening in this section. We did this with quadratics, and I don't know that I'm going to have you do much in your homework, but I just want to mention that if it works on quadratics, then it would work on a rational or a radical equation that turned into a quadratic. So anytime you hit a quadratic equation, you now have 2 options. One is complete the square and one is factoring. Given a choice, try for factoring. It is easier. But I also hope that you find as you practice quadratic formula and you remember which steps to do, that it's actually a pretty slick trick. It doesn't really take that much work. I find people think that it's this really hard thing, but I think it's just at first hard to remember. So as you keep doing it, it should get really quick. It's really just a couple of steps to rewrite this thing. So thanks for watching.